Hello everyone. In today's tutorial we're going to go ahead and cover flying pawn movement. We're going to create our own movement system in 425 and we can go ahead and move around all nice like this, and if we start holding the negative thrust button we'll start falling towards the ground. We can take back off again and regain our momentum. Alright, so the first thing that we want to do to get our project set up is setting up our input. So to do this we're going to go to Edit, Project Settings, and then we're going to go under the engine section, we're going to go to input. Right, so I already have my axis mapping set up, so go ahead and pause or do whatever you need to do to get a look at what I have currently set up. But in order to create your own, what we're going to do is we see this axis mapping's right up here. We're going to press the plus button. This will add a new mapping, and then we're going to just go call it new mapping. I'm going to set this value as going to be tab, and then press the plus to add in another one, and this is going to be left shift. You don't need to follow along for this current section. Left shift, there we go. I'm just demonstrating exactly how this works. So it will always try and go to whatever value you're holding down with a resting value of 0. So if I press and hold tab, it will eventually scale up to 1, and then if I press and hold left shift, it will eventually scale down to -1. So whatever value I'm currently at, let's say that I held tab for just a little bit, it's up to 0.5, and then I immediately press left shift to scale down to -1. It will go from 0.5 and then it'll start to -1. If I am not holding any button, it will go from whatever its current value is to 0 and remain at 0 until I give it another input. Alright, so the next stage of what we're going to do is actually creating our pawn. So let's go ahead and go blueprint class and then pawn. And then we're going to go ahead and call this BP underscore flying pawn. Perfect. Great. And then what we're going to do is usually you would use a static mesh, but we're going to go ahead and add a component so we can see our pawn. Usually you would use a skeletal mesh, sorry, but for this one we're using the UFO mesh, which is by default a static mesh. So for this instance particularly, we're going to do static mesh. Great. I'm just going to go ahead and call this mesh. And then we're going to add in a spring arm component. And then underneath that, we're going to do a camera component. And the reason why it is dropping everything subsequently, so childing all of these objects, is because I had this selected when I added in a new component. So it will automatically child the next component under what you already have selected. So let's go ahead and click on this mesh and then type UFO, and that will pop up. Great. So the next thing that we're going to do is pop in some of the nodes and variables that we're going to be using. So we have a couple of floats. We're going to go ahead and call this one thrust. I'm going to change this to be a float type. Then I'm going to max thrust, and then gravity threshold. And then I'm going to go ahead and compile so I can give these some default values. Max thrust, bit arbitrary at this point, but this will make sense a little bit later. And then we're going to go ahead and create two vectors. We're going to go ahead and have this be forward vel being short for velocity. And then we're going to do up vel, up for the upwards velocity. Now you'll notice when we created variables, since I automatically defined thrust as a float and then press ++, it defined the next ones as floats. So it will always automatically take in whatever your last created variable was for that specific blueprint and that specific instance of the engine. So if I close the engine down and then press the plus button again, it'll start off as a boolean, which is just the default. Great. So we're going to go ahead and use our axis binding. So the next one we're going to need is thrust. We need the thrust axis event. And then going to refer here quick, so we have move up, move right, and roll. So we're going to do move up, boom, move right. Here we go. And roll. Great. Perfect. So to define a couple of quick things inside here, our mesh, we want to disable gravity. We want to check on simulate physics. And then our angular damping, we're going to set this to be 1. In the previous tutorial, in the 425 one, what I ended up doing was on tick, I was decreasing the roll, but we don't need to do that because all of the angular velocities, so the rolls and tilts and whatnot, Unreal automatically does this for us, so we don't need to do that. So we're just using the angular damping that is provided. Now, if you needed to have some particular constraints to this for whatever reason, then you'd want to go ahead and set that up on your own. You'd want to set up your own angular damping if you wanted to be completely explicit with how you're controlling this. So the next thing that we're going to do is initialize our thrust. So for this, what we're going to do is take our thrust, we're going to set it, and what I'm going to do is just take our max thrust and then divide this by 2. So float divided by float, boom, 2, great, plug that in. This is just the default value. You can kind of make this whatever you want. I'm just setting it so that we're operating at half of max thrust, and so what we're going to do is comment this, call it initializing speed. Great, that's done. Then the next thing we're going to do is work with our thrust. So roughly what we're doing for this is we're going to actually we're going to make it so that we're only going to be adding or subtracting from our thrust when we're inputting a value. So if we're neither holding our W or S in this case, then we're just not going to change our speed. So if I hold W until we're at maximum velocity and then I just let go, we're not going to do anything unless we start holding S to decrease our speed, in which case we'll decrease our speed, and then if we stop decreasing it by stopping holding S, we're not going to change anything. Great. So what we're going to do is have a branch off of our pin 1, and what we're going to do here is check to make sure that our axis value is not equal to 0, because our holding value is going to be at 0. So when we stop holding the button, it's going to floor to 0. So we're going to do nearly equal float to 0 default, great, and I'm going to do 0.1 as a little bit of higher tolerance, and then we need to do a not. We want to make sure that it is not equal to 0. Great, plug that in. Perfect. So we're going to use a couple of nodes. First off, the end result will be setting our thrusts. That's it there. Then we're going to use an finterp2. Plug that in. We're going to do our thrust. Is this one. And then we're going to have a lerp, float lerp as our target. Get world delta seconds. And finterp2, by the way, all this really is it will try and get to our target value based off of our current value given delta seconds and a speed. And this speed I believe we have set as 0.25. Great. And then this is going to be from 0 to our max thrust, depending on our alpha value, which we're going to set in a second. But we're having our alpha be 0 because given it's a jet, we're not going to program this to be able to go backwards because that'd be kind of silly. But our max thrust is obviously going to be our maximum value. So this will end up smoothly trying to ramp up from our current thrust to our maximum thrust. And then our axis value from 0 to max thrust is going to be plus float divided by float. And why are we adding to our axis value and doing all this math? Because math is ugly. We don't want to do math, but why are we doing this? So as we stated earlier, inputs work as a value from -1 to 1. So if we want to take a value that ranges from -1 to +1 and make it so it ranges from 0 to 1, which is how lerps work, we're going to add 1. So then this would immediately go from 0 to +2, and then we're going to divide it by the maximum value there, the 2, and this will then make it so it ranges from a value of 0 to 1. So perfect. this should be all good to go. Good beans. Great. So then we have our lovely pin here. What we're going to be doing from here is setting the value of our forward velocity. We're going to do get actor forward vector. Great. And then we're going to do float times vector. Great. Vector times float. We're going to plug this in. Great. And then we're going to take our thrust and we're going to plug this into our float. There we go. Plug that in. And then this will actually be the vector that we use for our final physics calculations. So the way that this works, the actor forward vector is basically the vector that is pointed in the forward direction of our actor. So we click on our camera here, and we see this red X, a red arrow, which is the X vector, the forward vector in Unreal. And we're basically multiplying this red arrow times our thrust, and that gives us speed when it is plugged into a physics calculation. The reason I'm not clicking on the UFO is because I click this and it doesn't show me the red arrow. So demonstration purposes, yay. So this is this all set up. So we're just going to go ahead and comment this bubble and say calculating forward thrust. Great. So the next thing we're going to do is work on actually plugging in some of our velocity. So we're going to calculate our upwards gravity, and we're going to also calculate, actually apply the physics of this. So we're going to go ahead and do a sequence pin. And the first thing we're going to do is actually work off of our then one, and we're going to do set physics linear velocity. Yep, great. On our mesh, because that's our root component, that's what we want to use, and we're going to go ahead and drag our forward velocity and upwards velocity, and we're going to do vector plus vector, add these two together, and plug this in. And theoretically, if we press play, we should start being able to see our flying pawn moving. In fact, let's check to see if this is true. So yep, we see it moving, and then if we hold this, we should start slowing down. Yeah, it looks like we're slowing down, eventually getting to a crawl. Boom, we see it's working. Great. So now let's go ahead and start calculating our gravity here. So the next thing we're going to do is do a branch. Plug this in. And what we're going to do is get our forward velocity. We're going to do the length of this vector, so length. And we need vector length, and then we're going to do less than, less. Okay, we need to click on here so we can type less, float less than float. And we're going to do our gravity threshold. We're going to plug this in, boom, plug it into our branch. Done. And then off false, actually both of these are going to modify our upwards velocity. I'm going to plug in the false first because it is going to be less complicated. So for a false, we're going to do a v-interp2. Great. Copy, paste, delta seconds. This is a value of 20, arbitrary value. Set it to whatever you want. We're going to take upwards velocity. Boom. Plug that in. Great. So this is basically just saying that yeah, we just want to have it be no velocity over time if our threshold is less than that. Perfect. So we're going to go ahead and plug this in now. Move you a little bit out of the way because this is going to get a little bit messy. We're going to go ahead and plug this in right here. And so what we're going to do is get our actor up vector. Great. And we're going to get our actor rotation. Great. And we want to actually get our global up vector, so we're going to unrotate vector. Perfect. And basically the way that this works is if we drag our pawn into the scene, there we go. So right now our up vector, our z, is pointed up. But let's go ahead and say we rotate this guy. We're in local rotation mode, and we can see now that our z is pointed off to the side. This isn't really what we want. So if we're going to be scaling our upwards velocity by this, then we're going to start moving down that way. What we want to do is unrotate that vector so it looks like this. So when we say that we're below a certain speed, we start going down this way, because that's the way that gravity works. So what we're going to do is we're unrotating the vector, so we get the up vector, we unrotate it, and that gets us our proper actual world aligned up. So perfect. And then we're going to do vector times float. And how we're going to do this is we're going to plug in a lerp. Float. Yep. And then we're going to go from 0, which means not going down at all, to negative 980, which is the rate of gravity adjusted for Unreal's units, which is centimeters. So this would be negative 9.8 meters per second, but because centimeters, this would be negative 980. So perfect. And we're going to plug that. Oop, hello, thank you. Grab this pin, not the whole node. Then we're going to go ahead and thank you, Unreal, for being cooperative with me. We're going to get the length of this vector, and we need to do some math. Float minus float. Great. 1 minus this divided by the gravity threshold. Gravity threshold, plug that in. Plug this into the alpha. Gravity threshold, so that should be working. Awesome. So this should automatically now be working for pulling our ship downwards towards the ground. Because we plug this in, that has a default value. Great. So let's go ahead and start this. So we then slow down. We should start seeing our ship start going down. There we go. Now we can see, boom, we're going towards the ground, which is exactly what we want, or not what we want, depending on your perspective there. Great. So the next thing that we're going to do is actually work on turning this thing. So actually making it so we can roll or turn is going to be the easiest part of this video. We're just going to go ahead and name that thrust and gravity. So we're just going to go ahead and use these. It's basically going to be the same set of functionality copied over and over. So let's go ahead and add torque in degrees. Boom, plug that in. Great. And then we're going to go ahead and do get actor right vector. I believe this is the one that we want. We're going to do vector times float. Let's call it 20. Great. Actually, float times float. I'm going to do 20 for this. There we go. Perfect. Let's make sure that we're using the correct vector real quick. None of these are working. Why is that not working? Move up, acceleration change. Does that need to be checked? Whew, yes it does. Ha, okay, hello. Ooh, okay. Let's try something like 4. Perfect. But that was the correct one. I was using the mouse. That worked perfectly fine. So we're going to go ahead and plug in our next one. And then what I'm going to do is copy all of this. Copy. Actually, copy. Move right. So this is going to be the up vector. Get actor up vector. Plug that one in there. Plug this in right here. Plug this in. And paste that real quick. We'll use that for the roll. And that will be the forward vector. Great. So move right. There we go. We can see that we're slowly turning. Let's exaggerate this for a second just so we can really see this happening. Just to prove it works. Oh, we got to click. There we go. And now we can see it happening much quicker. Perfect. And then we're going to do our roll. We're going to plug this in. Hello, thank you. I would promote these to variables so you can modify them. Forward vector. Perfect. We're going to set this as 15. Not 150. Press period there, so we get 15. Great. So now this is going to be Q and E. Oh, this is super slow, which we can speed it up if we use our mouse, which is kind of cheating. So really, technically, you should probably clamp this if you have multiple values, like we have multiple values for our input in here, like you'll see for the mouse X. So you probably want to clamp the value there. Actually, which is pretty simple. I'll just show you how to do this real quick. So we're going to do clamp, flip, perfect. Minimum value, haha, -1. Maximum value, 1. Already set it that way, perfect. So that way, I can't cheat and do this. Oh, hello, thank you. Ah, now I'm pressing Q. So now this is me trying to use my mouse as well, and it's not working because we fixed it. Good. So this is actually, yeah, this is everything working, and we can modify our camera a little bit. So let's go ahead and set some stuff up with the spring arm to make this not feel awful. 1010, and then default value of 100. Great. And then we're going to go ahead and do the target offset. Oop. Unreal's mad at me. There we go. 150. That's too much. 100. No, that's 10. That's also still 10. There we go. I would probably adjust it a little bit, but it's fine. It works. It gets the job done. You can see we can fly around, do all these things. And if we start slowing down, we start falling towards the ground. Oh no. There we go. Now we're good again. We got our jet movement and everything set up perfectly fine. Awesome. There we go. Yeah, so this is the tutorial shaking out. That's good. Everything works just as intended. So we're good. We did it. All right, and that's how to program jet movement in Unreal 425. If you guys have any further questions, comments, or would like to suggest any potential videos, please feel free to let me know in the comment section below.